They have the most advanced pump technology in that wet lab right there we're going to see, probably in the world, for testing pumps in-house. When you're looking at irrigation efficiency, you're looking at whether or not that drop of water that comes out of there and makes it here, even though it's not used by the tree for transpiration, it might be used to wet the beds or to set fertilizer or something like that. That's efficient. We're just looking at uniformity. We're looking at every single one of these. We can find things with looking at DUs that can point back to inefficiencies in the pump. So that's all we really know. Main line, sub-main, lateral, risers, and at the end of every single lateral are flush out valves, and those are for getting sand out. Every time we do a DU, it's going to be by set basis. You can't do 2 sets at one time. It's what's irrigated on it at that certain time. So we ask the grower, okay, where's your set? We're taking pressure measurements along this lateral, and we also have to identify the lateral. The way the system works is it understands the relationship between flows and pressures, distance away from the pump, distance along this lateral, distances along this line here. It's able to give you the distribution uniformity. We just have to map it out and know where we're going. And once you know where you're going, then you just go do it. So we punch the hole, feed a tube in, take the pressure, straight out, and then we'll take flow readings after that. Well, the in is 27 and the out is 19. So we're losing a lot through the sand medium.
27, yeah.
We're going to get this water from right here. So you can take one right here, either right here or right here, then right here, and right there. So the first thing we did was we figured out the locations of where we're taking pressures. We know that now. Second thing we're doing is the locations of where we're doing the catch cans, which isn't always the same place where we're taking the pressures. So a lot of times they may have a pressure regulating valve right here that says, okay, I'm only allowing 20 psi through here. Here, they don't have it. Whatever comes through this line gets sent out that way. There should be a pressure regulating valve right there, and they don't have one. Okay, what was our pressure coming out of that right there just by
19?
So what do you think it's going to be here?
About 14,
something
15,
less than 19, yeah.
Less than 19.
Oh yeah, how we all have phones.
There we go.
Okay, mark that one as no bueno.
What's number 50?
Boy, this is going to be a really cruddy DU. They're at 11 and a half or 12. Oh, man, they got 19 right there and they got a 12 right here.
On the first line.
12.
So we're going to start off right here. We're going to do 16 consecutive emitters. And go. And you always got to make sure that it's hitting right. And go. Get that going. You don't want to lose any water at all. 3, 2, 1, out. 2, 1, out.
Definitely.
Not a good water.
What? 27. Bottom of the meniscus. Huh? What's the application rate per acre in acre inches for 24 hours for this set of emitters?